We will start again our meeting and scientific sessions about radio frequency and health in potential health impacts. It's also maybe my pleasure to say that we have had this morning more than 550 people connected, so meaning that this meeting is very active, not only here in the room but also in distance, and that's why it's also important to share and to save time for transmitting the questions that are shared by our distant participants. They are distant, but they are here, in fact. It's my pleasure, and in the beginning of this afternoon, to welcome again Dr. Weiderpass, head of the IARC, and in fact, because she does not only take the whole day with us, which is a great honor for ANSES, but also take an active part, and she will be moderating this session number 3 about radio frequencies and cancer, of course. Your floor is yours.
Thank you, Mathieu. Merci beaucoup. Alors, j'ai le plaisir de présenter.
It's my pleasure to introduce to Dr. Joachim Schüz, my colleague, in charge of the Cancer and Environment Unit at the International Agency for Research on Cancer, and he's going to be giving us a general presentation on radio frequencies and cancer. The present, voilà.
And I think also better for you giving my pronunciation in French. So first, before going to the talk, maybe something about IARC, because the scientific priorities of the research that IARC is doing is following a strategy that undergoes scientific revision every 5 years. So I'm really pleased to tell you that research into non-ionizing radiation has been on this research agenda since the late 1990s now. And this is one of the reasons why we have this very much engagement and dedication to really find answers to this question of whether radio frequency applications, and here specifically the mobile phones, are posing a risk of cancer. And this is also why you probably see IARC appearing multiple times in the agenda of today, but that is also why I'm very pleased to give this overview on radio frequencies and cancer for you today. You have heard that IARC is actually not only... Is that a trick? You've heard that IARC is actually not only research, but IARC is also having this IARC monograph program on the identification of human carcinogens. And you heard that there was an evaluation published in 2013, but the actual meeting took place in 2011 with the result being published where radio frequency fields were evaluated according to their carcinogenicity for the very first time. And the IARC monograph program is evaluating all the lines of evidence first separately, looking at the cancer in humans, which is mainly the observational epidemiological studies in this case, looking at cancer in experimental animals, and looking at the mechanistic data, so data that informs whether what you see, for instance, in the observational studies could be a causal effect or maybe not. And first, the 3 lines of evidence are evaluated separately to see whether there's sufficient evidence for an association or whether there's limited evidence. And this then comes together in an overall evaluation. So cancer in humans at the time in 2011 has been evaluated as limited evidence, saying that there were some signals in the studies, but it could not be taken as sufficient evidence to say that there's a causal association between exposure and the outcome. And also cancer in experimental animals has been actually ranked as limited evidence. And this explains why overall it ended up in this group 2B, which says possibly carcinogenic to humans. And this is, of course, not a real-life condition. I mean, real life means something is carcinogenic or something is not carcinogenic. So possibly carcinogenic is an expression of scientific uncertainty that we have. And this is showing us that there are some signals that we have to be taken serious. And we need more research that sooner or later, eventually, of course, radio frequency fields end up in one of the classes that are really corresponding to the real life. So to discriminate because we have used hazard, we are using risk of what these two things mean. So the hazard identification more or less comes up with a yes-no question. Something is carcinogenic or not. And this is where really the epidemiology, the experimental animal studies, and the mechanistic data comes together. And then, of course, when we go to the human, we do not want just to know whether something is carcinogenic. We need to know what is the risk for the individual. So given a dose of the exposure, how does this change my cancer risk? Because we have some exposures, for instance, which are very high cancer risks, and we have other exposures which are low cancer risks, depending on the dose. So we would want to know, even if mobile phones turn out to be carcinogenic, how much do you have to use a mobile phone to reach a certain cancer risk? So this is the risk for the individual. And this is not part of the hazard identification. This comes as the second step. And from knowing the individual risk, we can estimate for the population what the effect is. And this is what we know for the public health measures. So we need to know how many people in your population are exposed to this carcinogen at certain levels of individual risk to make an estimate of how many cancers could be prevented in the population. So in the ideal world, you have a situation like we do have for artificial UV radiation. And this is the example here, because we know from the mechanistic studies, from the epidemiology, from the animal studies, yes, this is carcinogenic exposure. We have very good epidemiology data that we can estimate that one session of sunbed use per year would increase your risk of melanoma by almost 2%, meaning that if you use a sunbed once a week, it would double your melanoma risk or would increase your melanoma risk by 100%. And then we can apply this data to the French populations. From surveys, we know how many French people take how many sessions of sunbed use. And we know that if we would stop this exposure to artificial UV, we could prevent almost 400 cases of melanoma in the French population. But unfortunately, for the radiofrequency fields, we are not like that. We are still stuck in the first step, not knowing whether it's carcinogenic or not. But we do have some evidence. So when we evaluated in 2011, the main driving study was the so-called Interphone study, which was the largest study of this kind at the time, which was a study conducted in 16 centers in 13 countries, looking at 3 types of brain tumors with overall more than 6,000 patients and more than 6,000 healthy subjects. You can see the ascertainment was in 2000 to 2003. So from today's perspective, they were all using mobile phone technologies that are not even existing anymore. This was a study coordinated by the IARC. And the reason why the findings were taken as so exciting was what you see in this dose response curve here. So this is the way that we epidemiologists present our risk results. So we look at the occurrence of the cancer in the exposed group, and we look at the occurrence of the cancer in the non-exposed group. And the ratio between the two is what is plotted in this graphic here. So if you have a ratio of 1, that means there's no association, because the occurrence in the exposed group is exactly the same as the occurrence in the non-exposed group. And then when you follow this curve here, then you see that actually in the classes of moderate mobile phone use, you rather see estimates below 1, which would be a suggestion of a protective effect. And in this group of the heaviest users in this study, we see an increased risk of glioma, which is very interesting, because glioma, this is really the one fatal type of brain tumor, which would be, of course, of very high priority if it could be prevented. So if you translate these studies into the population risk, then we can for the time say that at this time, about half of the population did not use a mobile phone regularly, which was not at least 1 time per week. Almost the other half of the population had no increased risk or even slightly decreased risk, which was using the mobile phone occasionally or frequently, but not heavily. And for the about 5% of the population that used the mobile phones very heavily, we found this moderately increased risk of 40%. And the problem was that at the same time in Interphone, we did some validation studies, seeing how well do people respond to the questionnaire. Because you can answer the question for yourself. I mean, the screening question in this study was, how many minutes per week did you use your mobile phone 10 or 15 years ago? This is, of course, not an easy question to answer. It comes with some uncertainty, not even intentionally. It just comes because you can't remember. And these uncertainties, of course, affect the epidemiological studies in a way that is inherent in the whole design, because for cancer, we need to know the past exposures. We don't need to know the today's exposure, because cancer develops over 10, 20 years. So we need to know what was the exposure of people 10, 20 years ago. And this is very challenging to assess, and this adds to the scientific uncertainty that we have in our results. So we could not conclude that this finding is a causal association, because in the validation studies, we saw that people have difficulties in remembering their past mobile phone use. So this is why we also tried some other designs. And this was using studies that were not even particularly designed to address the question of mobile phone use and brain tumors. But I had data that we could use for this purpose. One is a study in Denmark where we used the whole 4 million Danish adult population and put them just into two groups. It was the early mobile phone subscribers before 1995, and it was all the rest. And you can see that there's not a big difference between the two. The brain tumor risk were exactly the same in the two groups. And another big study was the UK Million Women study. As the name says, enrolling 1 million women in the UK. And here there was some rudimentary information about mobile phone use. And you see that the women who used the mobile phone for more than 10 years without having any information on the amount of use did also not have a higher brain tumor risk. So these studies certainly cannot address the question like interphone, whether heavy users have a higher brain tumor risk because they simply did not have this information. But there are very strong evidence that ordinary use of mobile phones cannot be associated with an increased glioma risk. So what has happened since 2011? First of all, there were two very large bioassay studies, one conducted by the Ramazzini Institute, the other one by the National Toxicology Program of the United States. And this was really a lifelong observation of rats that were intentionally exposed to different levels of radiofrequency fields. So you see in the Ramazzini study, for instance, 19 hours per day where all these rats are exposed. With varying levels of exposure between 0.001 to 0.1 watt per kilogram. What they observed was an increase of heart schwannoma, which is a very rare tumor in humans actually, in male rats at the highest dose, and no increase in the female rats. In the NTP study, they used higher exposures. You can see between 1.5 and 6 watt per kilogram. They also had an intentionally overexposed group, and the rats were exposed 9 hours per day. They also saw an increase in heart schwannoma in male rats, not in female rats, and also not in male or in female mice. So there are some indications from these findings for the heart schwannoma. What is the difficulty with the studies of how do you interpret this exposure that the animals received to our situation of humans by using mobile phone and walking around freely in an environment where we have environmental exposure to radio frequency all the time. So it's not very straightforward. And this picture is not necessarily from the studies, but it reminds you, I mean, putting a rat in a field is automatically different than holding a mobile phone to the head, because you see the whole animal is exposed, and when you hold it to your head, it's a relatively localized area of the brain. So the question could be, is the thermoregulation here really the same? And especially the cumulative exposure over time in humans is more or less representation of your average use, while in the animal experiments, it was mainly peak exposures being used, so the highest exposures from the mobile phones or from the environmental sources. And of course, hardly any human is exposed to these values. So if you calculate a lifetime exposure, then there's a tremendous difference here between the animal exposures and human exposure in daily life. There's also new epidemiology, one study coming out recently, actually in 2022, which is an update of the UK Million Women study. And again, with a larger number and longer follow-up, we didn't see an association. We actually got some interesting additional data, which is namely on the location of the brain tumor. And of course, as I already said, when you hold your mobile phone to the head, it's also not your whole head being exposed. It's really the area like 3, 4, 5 centimeters closest to the mobile phone. So we would expect, if there's an association between the exposure and the brain tumor, that it should more affect the brain tumors that are also at the temporal lobe in the brain or the parietal lobe, but not so much the frontal tumors or tumors in the just in the center of the head. And we did not see a difference actually between the locations of the tumors, which confirms the finding of no effect in this study. Otherwise, there's not much new data, but I've seen there's a lot of meta-analysis being published. So just for your information here, I'm wondering a little bit whether there's now more meta-analysis than original studies, in fact. And of course, they are more or less coming to the same conclusions as also the IARC evaluation, as also the evaluation by the European Commission, by the Scientific Committee on Emerging and Newly Identified Health Risks. And more or less, there are nuances in the difference, depending on whether the people put more weight on these potential biases or not. And I would really say, don't do any more meta-analysis. They will not reveal something new. Maybe it's better to wait for some new data for a change. There's 2 studies that came out in the meantime on children and young adults. And this, of course, was also driven by concerns that children might be more vulnerable because of their developing brain, because of all these difference, the size of the head, the radioelectric properties of the brain. And this is why we started also brain tumor studies in children. The first one being published was the so-called Cephalo study, which was done in 3 Nordic countries and in Switzerland for the age group 7 to 19 years. You can see 350 cases, twice as many controls. There was no clear effect. There was really a little bit of an increased risk between the never users and the ever users, but we did not see any trend within the ever users of the phone. And a study that has been mentioned here already, the MobiKid study, which was published early this year, which is 14 countries, age group a little bit older, 10 to 24 years, 900 cases. So if you look at their crude results, then you see surprisingly that they found actually an inverse association between the brain tumors and the mobile phone use. But correcting for some of the errors that they observed in their study makes more or less a null effect. So taking these 2 studies together with over more than 1,000 cases now does not really provide any evidence that brain tumor risk in children is increased due to mobile phone use. We also did recently at the agency a look at the brain tumor incidence rates, or specifically the glioma incidence rates. I mean, normally this type of ecological studies is not fully informative because these time trends can be influenced by so many things. It starts with diagnostic procedures, with referral patterns in patients. And of course, you're not only exposed to one thing in your life, you're exposed to many lifestyle factors, other factors. So you never know which are the driving factors here. But what we can use it for is a consistency check. Because the studies, case control studies and cohort studies carried out on samples, they come up with a certain prediction of a risk. And if we model this prediction of the risk to the population, we see a hypothetical change in the incidence rate, and that we can compare to the real incidence rate. And if the 2 are compatible, then it's good. And if the 2 are not compatible, then this suggests that actually the studies based on samples, self-reported information, may have suffered from methodological artifacts. And this is working for the mobile phones because the exposure is so prevalent. I mean, it works like for tobacco and lung cancer because tobacco is the driving cause of lung cancer, as we know. And of course, with mobile phones, we have an exposure that nobody had in the mid-1980s, and that probably close to 100% of the population were already exposed in 2010, 2015. So if with ordinary use of mobile phones, there would be an association, we must see the effects on the incidence already. And if you don't, then there's either no risk in the ordinary users, or it would be so small that it would be beyond the detection level in these incidence studies. So what you see here is differently for men and women, for the different age groups, how the incidence rates really look like. And then you see that specifically the age group of 40 to 59-year-olds, which is the age group where the mobile phone use became prevalent much earlier than in young people and in older people, that there's no change over time. You see an increase in glioma risk. In fact, in the very elderly, specifically in the age group 70 to 84. As you can see, this increase started already in the late 1970s, so even before any mobile phones were on the market, and doctors, neurologists have an explanation for this. And this is mainly that the diagnostic procedures have become better, first with the computed tomography, later with the MRI, to diagnose much smaller tumors than we were able before. So what this study, however, shows us that the overall result that we see in interphone, for instance, is not really compatible anymore with the incidence rates, because we should see an effect by now if this 40% risk increase for heavy users was just persistently there. However, it could be a possibility, because interphone looked only up to the GSM generation, that it was only the older generation that also had a higher output power that were related to an increased risk, and the subsequent generations from 3G to 4G, of course we have no data on 5G yet, with a much lower output power, that people did not reach the same exposure level than they did actually in the 1990s. So that is still a possibility that is there. There have also been case-control studies, especially like from Sweden, which showed actually a risk increase for practically every mobile phone user. If this was true, then we should see a clear effect in the incidence rates, which is what we don't. So this is why I have no more details on this study, in fact. I am close to concluding. Thank you. Just coming back to the monographs, because there has been a discussion on when would be the next evaluation by the agency, because 2011 is now more than 10 years ago. And when the advisory group on priorities met, their recommendation was, first of all, they recommended a re-evaluation by IARC for the second half of the 5-year period. So that would be earliest 2023, but also 2024. And they also said you really have to wait for new evidence. Otherwise, it makes no sense to do a re-evaluation if the evidence is still the same. So they said the cancer bioassays in the animals are very important, and they have been published by now. And they also said we need the epidemiology in place. So 3 studies were mentioned. UK Million Women study published already. MobiKids is published already. So what we are waiting for is the study presented by Elisabete this morning, the Cosmos study, which is really also the first cohort study designed to address the question of the association between mobile phone use and outcome. So it is a very influential and important study. The re-evaluation meeting would be announced 1 year in advance, so you will not miss it when it's announced. So finally, these are my conclusions. So looking at the cancer hazard, there is the possibility of carcinogenicity because it was confirmed in large animal experiments. However, the animal exposure used in these experiments is not easy to interpret what it means for humans as their lifetime exposure. If you look at the human risk from the cohort and the case control studies, there's from the interphone study the possibility of a modest risk for glioma in the lower than 5% heaviest users of mobile phones. However, this is possibly only related to the first 2 generations of mobile phones with higher output power. As a precautionary measure, because we have discussed precautionary measures in the morning, remember that when you do a long phone call, you can always use a hands-free set, and this brings your exposure, even as a heavy user, down to the exposure of an ordinary user, which is a group where we are relatively convinced now would not have a higher brain tumor risk. And if you look at the population-level studies, there's no evidence of any detectable population risk of any type of the brain tumors by now. And this is my end, and thanks for the attention.
Merci beaucoup, Joachim. C'était une présentation extrêmement claire et les conclusions.
This was a very clear presentation, and the conclusion were very clear as well. We're not going to take time for questions right now. We'll keep the questions for the end. We're going to move on now to Liacine Bouaoun's presentation. He's with the IARC, and he'll be talking about the effects of the recall bias on the modelization of the risk of glioma linked to the use of cell phones.
Okay, good afternoon, everyone. So my name is Liacine Bouaoun. I'm a biostatistician working in the Environment and Lifestyle Epidemiology branch at IARC, WHO. My presentation will be on the effect of recall errors and selection biases for mobile phone use, and brain tumor risk. So here is my disclaimer, where I have no conflict of interest related to the present work. So the presentation of today, I will first start by describing the rationale of the project, where the project stems from. Then I will present the main objectives of the project, and finally, I will report the main result that we obtained. So what about the rationale of the project? So IARC has classified radiofrequency electromagnetic fields as probably carcinogenic to humans in 2011. And people are concerned that EMF through mobile phone use may increase your risk of developing some types of cancer, like brain tumor, for instance. In this context, the international case control study Interphone, conducted between 2000 and 2005, reported a positive significant association for the risk of glioma with a G-shaped relationship between the decile of mobile phone and the risk of glioma, as well as the 40% increased risk among heavy mobile phone users. As you can see, with this figure that also Dr. Schüz presented just before. Since reduced risk was also observed among low and moderate mobile phone users, which was interpreted as biologically implausible, the key and most debated question was, would this association that we can observe be due to bias? So in this context, it was of particular interest to investigate what types of biases would lead to a spurious G-shaped relationship. Okay. What about the objectives? So, in fact, there were two main objectives in the Intercal project. The first objective was to create a coherent model of the various uncertainties and biases that we observed in the main Interphone study to allow a clear and valid interpretation of the reported results. More specifically, the idea was to apply a mobile phone use recall error to an hypothetical dataset of no association between mobile phones and the risk of glioma, and then to examine whether risk estimates obtained from this hypothetical dataset are compatible or not with those reported in the main publication. Secondary objective was also to extend the risk modeling approach that we use for mobile phone use to the field of environmental exposure to pesticide. Nevertheless, my presentation will only focus on the first objective. So, to address the first objective of whether the increased risk that we observe among heavy mobile phone users could be due to an assumption of no association between mobile phones and the risk of glioma, once reporting errors are accounted for, we decided to conduct a Monte Carlo simulation study based on a case control study design to mimic the full model used in the Interphone study. Input parameters were derived from two validation studies of Interphone, conducted in parallel to the main study, where both self-reported and operator-recorded data were available. Data were simulated under the assumption of no association, as I said before, and we use exposure in categories in this slide exactly. Both true and error-prone mobile phone use data were generated in this simulation study. We decided to use a Bayesian hierarchical analysis model to account for the potential heterogeneity between the Interphone countries. And several types of reporting error were investigated, all based on what we observed from the radiation study. I will just come back to just after this slide on the different type of scenario that we investigated. And lastly, we also try to see if there is an association or potential correlation between the reporting errors and also the true level of mobile phone use, suggesting, for instance, that the more you use your mobile phone, the more likely you are to make reporting errors, and vice versa. So the different types of mobile phone use error that we considered. In fact, we considered differential random and differential systematic errors, and also a scenario combining both differential random and differential systematic errors. Indeed, from the validation studies, we observed overall that cases have greater reporting error than controls. And also, on average, higher cases have roughly 30% higher reporting error than controls. And also, a similar pattern was observed for a greater systematic reporting errors. between cases and control. So what about the result that we obtained? So if we look at the mobile phone use data itself, we observed another representation of regular mobile phone user compared to non-regular mobile phone user, especially among controls. And we also observed a systematic exposure misclassification with an underestimation of mobile phone use among low users, and conversely, an over-representation of mobile phone use among heavy users. And lastly, unlikely self-reported mobile phone use data were much more common among cases than controls. So here is the main figure of our simulations, presenting risk estimate on the y-axis against the decile of mobile phone use on the x-axis, based on the most interesting bias scenario, where we assumed first no association between mobile phone and the risk of glioma, as I said before, and also assuming that cases have greater random and greater systematic error than controls. So you have two types of color, a green color and a pink color. The green color represents risk estimate associated with the true level of mobile phone use without any reporting errors, while the pink color showed the result associated with the bias scenario, associated with where mobile phone use data is associated with reporting errors. So as you can see, the pink risk curve leads to a spurious G-shaped relationship between the decile of mobile phone use and the risk of glioma, and also with an apparent excess risk among heavy mobile phone users. So as you may already have noticed, this figure is extremely similar and fully compatible with the risk function that we observed in the main interference study. This is the first figure that I presented, and also a figure that Dr. Schüz presented during the previous presentation. So we can't exclude the fact that the positive significant effect observed among heavy mobile phone users could be an artifact due to reporting variation of reporting errors in the absence of any real effect. Just to conclude, the G-shaped relationship that we observed in the main interference study is fully compatible with an assumption of no association between mobile phones and the risk of glioma. And it suggests as well that the excess risk that we observed among heavy mobile phone users was potentially an artifact and not a causal. And lastly, I also wanted to draw your attention on the fact that it's probably unlikely that results from case control studies only will address the question of whether mobile phones are associated with an increased risk of glioma due to uncertainties and biases inherent in the study design. Fortunately, additional prospective cohort study, like the COSMOS study that Dr. Elisabete presented this morning, will help to overcome those limitations and will help to address this key question. So I wanted finally to acknowledge all the collaborators of the project, especially Dr. Schüz and Dr. Burns, as well as ANSES for funding this project. So thank you for your attention, and if you have any questions.
Thank you. Thank you so much, Liacine. Are there any questions from the floor? Yes, I see the lady in the middle and then the Mr. on my left. Lady in the middle, please.
Hello.
Hi.
You made the assumption for your model that you had no effect. Could have you made the other assumption and the assumption that there was actually an effect, and what kind of consequence this would have on the type of bias that would be observed? I don't know if I'm clear. It's because you interpret the shape as a bias in the representativity or the self-rating of the evaluation of the level of use or things like that. And so if you consider that this shape was actually an effect, would you have a different conclusion on the models or on the bias that would...
Yeah, if I were understood, you have two different types of questions. The first one was, did we also consider the scenario where there is an effect of mobile phone use on the brain tumors? And the answer is yes. We also observed an increased risk. And to address the second question, we did not specify because if I can go back to the results quickly. We did not specify that we wanted to obtain a G-shaped relationship. This is the result that we obtained at the end. But a priori, we did not specify that the relationship between the decile of mobile phone use should be distributed as a G-shaped curve. This is what we obtained at the end. I don't know if it addressed your question or not.
Yeah, but it's what you obtained with the assumption that there is no effect.
Yeah.
And the question was, could you obtain the same kind of shape with the assumption that there is an effect?
Yeah, we also observed a G-shaped relationship, when we assume that there is an effect of mobile phone use on the risk of glioma, but the curve is much more pronounced, I would say, and the point estimate is a bit different.
Thank you.
Thank you, Liacine. Then there was a gentleman in the third here, please, in the third line. Yeah.
Oui, bonjour. J'aimerais.
Yes, good afternoon. I would like to know from which level onwards do you define a heavy user, and to which extent the conditions under which we use a phone impacts the result. If you have, for instance, a phone that's crashing because you're very far from an antenna, does that have an impact, or whether you are close to an antenna and your phone is working perfectly? I can answer in French as well. As for the second question, the validation data for the interphone study does not make it possible to determine how far we were from the radio repeater. So this is a really interesting question. And the second thing, as to what is a heavy user, if we look at the interphone study, it's approximately more than 1,640 hours of use of the mobile phone over the whole lifespan of the person. Thank you very much. Do we have online questions from people virtually attending? Yes, we have some. Please go on.
One question to Joachim, and this one is, if the Million Women study only takes into account mobile phones and not DECT phones, which were abundantly around before, you might have heavy DECT phone users that distort the results. So could you comment on this?
I mean, again, for clarification, the UK Million Women study was not a study to address really mobile phones and brain tumors. It was that the data was available. And then, of course, we have to live with some of the limitations. So there were only questions on the mobile phone use. So it is true that we could not look at DECT users. So if the use of cordless phones and the use of mobile phones would be heavily correlated, it could have an effect also on the estimation of the risk of the mobile phones. If the two were not heavily correlated, the mobile phone result would still be robust, even if we could not take into account the use of the cordless phones.
Merci beaucoup, Liacine. Merci, Joachim. Vous pouvez rester là-bas. Et on va passer maintenant à Monsieur Yves Dréan de l'Université de Rennes 1 à Rennes, en France. Et il va présenter...
From University of Rennes 1, he's going to tell us about intermediate frequencies and genotoxic stress. Let me see how this works.
Hop. Donc bonjour tout le monde. D'abord,
Good afternoon. First, I'd like to thank ANSES for inviting me and making it possible to me to present this work that was funded by ANSES. I'm presenting it, but this is the fruit of a cooperation with the Cox team from Georgi Kowalski, who is in Budapest in Hungary, and Maxim Zadobov, who is in Rennes, France. And I work at the IARC, the Institute for Research on Health, Environment and Occupational Hazards, to check, to verify the impact on environment onto human health. So we didn't change, we didn't keep frequencies, we changed frequencies, and it was deliberate. We realized that there was a lack of data in terms of scientific data and biocompatibility of these intermediate frequencies, which are just between very low frequencies and radio frequencies. On radio frequencies, we have a lot of surveys that were carried out for due to mobile phone use, and very low frequencies also because of the problems related to high tension lines. For intermediate frequencies, we're going to accumulate these two effects. We are going to have thermal impact, but also a difference with very high frequencies, especially as many applications are appearing and you can be exposed to such frequencies. You see here a couple of examples with the induction cooking devices, the Linky meters, and the wireless energy transmission systems. Wanting to study them is a good thing, but what should one look at? Well, we paid attention to genotoxic stress, which comes from the analysis that was made. We realized that for this genotoxic stress, we had data for low frequencies and very low frequencies with contrasted data, sometimes result, sometimes no result, and doubt remaining. Genotoxic stress is a very broad field. We can do a lot in this field if you're not used to it. It's the damage to DNA, and you can have many of them in the cell, and we have a whole range of enzymes which are working to repair these damages, which makes these surveys even more difficult because you can not look integrally at these systems, which are very complicated. One has to underline that these waves, whether they are radio frequencies or lower, it's very difficult to see their impact on DNA cells. So we have to look at indirect impact. So you can imagine some modifications in the metabolism. What comes out of the current literature is some oxidating stress, but this is not very strong. And some impact on the repairing enzymes. For instance, exposure could inhibit the action of these repairing enzymes. But we could have also the opposite effect, that is a positive impact of radio frequencies. We have publications that show such effect, that is an adaptive impact with radio frequencies, which would make it possible for cells to manage better genotoxic stress, producing another agents such as some chemical. And we have the case of this king in ancient times who was taking some small doses of poison to get used to it and not let anybody take his place. Here we have some comparison systems that were made by my electronic engineer colleagues. This means that we're going to be able to manage some low frequencies radiations, such as 22 kilohertz. We can mimic some engines, for instance. And then the second system, that is around 10 megahertz, 13.5 exactly, which is going to mimic some transmission systems for such as the energy transmitted to charge batteries, and these are intermediary frequencies. Some results very quickly. As you know, our schedule is very tight, so I'm going to try and be quick. We have many possible tests in the field of toxicology to assess toxicological stress. Here you have the COMET test. The principle is quite simple. We are going to see whether there are breaks in the DNA, whether we have fragments, and we're going to have many small comets here that are representative of the breaks. And then you can compare with intermediary frequencies. We also looked at the activation of repairing systems. When you have such breaks taking place, you have repairing systems that are activated, and they need a switch-on, switch-off system. That is, if there is no break, they're not going to be active. If there are some, they're going to be active. And we have post systems that make it possible for an enzyme to become active or inactive. So antibodies, specific antibodies, are going to be used to reformulate these enzymes, which would reflect the activation due to these exposures. Here you have the foci, and on the other side H2AX, which is better known. So we didn't identify such breaks, but we looked at other damages to DNA, and here we had some interesting results. That is, with the oxidating stress and DNA oxidating. Well, we had two types of tests. We could look directly at the oxidation of DNA through immunofluorescence dosing, and you see that with a 13.5 megahertz we have a trend that's on the increase. But using other types of techniques with 22 or 250 kilohertz, we have a COMET test that is going to identify such breaks. And we are going to have an increase, a significant increase, which reflects the harm to our DNA when exposed. We wanted also to assess the adaptative impact. This adaptative impact for 22 and 250 kilohertz, we couldn't see any. That is, this doesn't protect you from any harmful action later on. But with 13.5 megahertz, using not X-rays, but another oxidating stress, we could see not adaptative impact, but another type with some repairing action. We were quite surprised because we expected quite the opposite. And now let me tell you the conclusion of this work. If I need to summarize, we didn't find any direct breaks. Exposure is not that significant, but to get breaks in the DNA, you have to have something very strong. We didn't identify any trigger to the repairing systems of the DNA, but of course we don't have this switch off, switch on system that I was mentioning, so maybe some further work is needed, but the outcome of our work is quite interesting, which is why we'd like to go on working in this field with the magnitude of the work that is on the verge of being of significance, but we don't find this for all frequencies. That's quite surprising. And as for the adaptive effect, we couldn't identify any, whatever type of stress, but for the oxidating stress, we found some result. When I saw this, we manipulated other genotoxicity with other oxidating factors, and we didn't get the same results, such as that the order of exposure seemed also relevant. So it would be interesting to go on investigating. Do we have questions in the room? Yes, one here in the middle. Eric Vladimir, chair of the Committee for Discussions on Radio Frequencies. Well, it is a non-explored area. You mentioned 10 megahertz, and you mentioned mobile phones. I think there are other frequencies that could be investigated, such as MRI. I think it was around 100 to 400 megahertz. Do we have information on this? Well, very few. So this could be a topic for research. Well, there is a bit of literature, but compared to radio frequencies, there's very little. Do we have online questions, Isabelle?
Il y a plusieurs questions. Il y en a.
We have several questions. One is quite technical. The BER path for repairing of the 8-oxoguanine is activated in your model of survey. Well, the problem that is the specific system that detects oxidation and is going to get rid of nucleotides to repair them. It is quite a traditional system that is that has been part of the world since oxygen exists. We don't have this activation through phosphorylation of enzymes, so it's very difficult to see whether these enzymes are actually working. So we need to be more subtle and find new protocols. I'm pondering upon this currently. It's not simple, but I hope we'll manage. I don't have an answer yet, but it's something that's of interest to me, and we're going to have to identify tricks to be able to do this, because we don't have the right tools for the moment. Thank you very much, Mr. Le Dréan. We're now going to move on to Anne-Sophie Bonnet-Villégier from the National Institute for Industrial Risks onto the Environment in France, and she's going to tell us about ASTRO-RF, effects of cell phone electromagnetic field exposures on brain tumor evolution. Please. Good afternoon to all of you. I'd like to thank the organizers for giving me the opportunity to present this work. My name is Anne-Sophie Bonnet, and I work at the Ineris, and I'm going to tell you about ASTRO-RF, which is about the impact of electromagnetic field exposures onto brain tumor evolution. So it was funded by ANSES, PNR, on the environment and occupational work, and it was set up from 2015 to 2018. So it was about studying the impact of radio frequencies of mobile phones onto brain tumors evolution, development, and we paid attention to more specifically to heavy users to see whether there was a difference between them and the light users. So we had two approaches, one epidemiological approach with Joachim Soons, Isabel Olsen, and Anne Olsen, Isabelle Deltour, Véronique Luzon, and Liacine Bouaoun, together with the Danish Cancer Society in Denmark and other organizations from Sweden, myself and Luana. And I'm going to start by telling you about the epidemiological approach, then I'll move on to the experimental one. The aim of this was to survey the link, to study the link between the exposure to radio frequencies and staying alive after being diagnosed. This survey was carried out in 3 countries of Northern Europe: Denmark, Finland, and Sweden. A little reminder of Interphone: it is a broad study of case studies with 2,409 cases of meningioma, and it was carried out in 13 countries related to the use of phone, assessing the link between the use of mobile phone and the risk of development of brain tumor. So this was more about surviving after being diagnosed. So the data from Interphone had to be included in an analysis of global survival after diagnosis, that is in month. Then the use of the phone was being assessed, taking various angles: the regularity, that is how long it was that you'd been using such a phone, then the time spent phoning, and the time over the past 12 years, the 12 months before, being diagnosed. What was also taken into account were the characteristics of the tumor, its level, low or high, and its morphology. And we had some hazard ratios, analyzing the Cox regression models stratified per country with non-regular users as a reference group, a control group. We had also some covariables adjustments. So we had a minimum in terms of sex, age, and diagnosis. Age at the time of diagnosis, and a full one with sex, age, diagnosis plus treatment, physical location of the tumor, and the general physical state of the person. Now, in terms of the results obtained, we had 860 cases of glioma. We had an average survival of 42.5 months and a proportion of regular users of mobile phones of 57%. The significant association suggested better survival for the users of phones, and it was the same for high or low grade glioma. For instance, 6.6 month for regular users and 15.6 months for a non-regular user with a malign glioma. and the for the glioblastoma you could see on the screen. Let me tell you the results of what we had. So for the minimum adjustment on this column, let's pay more attention to this line, which represents the most heavy users. You have here the examination of the heaviest use. Here we have more than 10 years with the use of the phone that is represented in cumulated time until diagnosis. Here we have more than 777 hours, and in the last category we have the cumulated data for more than 183 hours. If we look at the top ratios, we're very close to 1, so the trustworthy intervals have 1. Now, depending on the grade of the tumor, we have the low grade or high grade. The rectangles that we have, here you see we stress heavy users, and you also see that the ratios are very close to 1.
So, as a conclusion, there's an absence of indication of a reduced survival rate in relation to the use of cell phones among patients with glioma. Second approach, we tested the hypothesis of an impact of daily local exposure to radio frequencies on the survival of rodents with a glioblastoma. We used a model that is well described for research on cancer, a rat model which enables us to study therapeutic aspects of the cancer. So we study the cancer cells, and rats. These are animals that are exposed daily, 45 minutes a day, 5 days a week to radio waves, to arrive at 0.25 watts per kilo, 0.5 watts per kilo, a cage control group who are not exposed to electromagnetic waves. And when the animal dies, then we note the survival rate and we look for anatopathological characteristics, including the size, the aggressiveness of the tumor, infiltration, vascularization, and the infiltration of immune cells. This study showed an absence of a link between the survival rate and the exposure to electromagnetic waves. Here we have the number of survivals per different group. Now for the characterization of the tumors, we obtained a significant reduction in the case of infiltration of cells, immunitary cells, but there were no differences on necrosis, proliferation, vascularization, or mitotic index. So there seemed to be no effect of the electromagnetic rays on the survival exposure of 45 minutes per day was meant to imitate intense exposure. We obtained the reduction of the apoptosis of the glioblast cells and infiltration of immunity cells in the microenvironment of the tumor. These effects are perhaps the conditions were not powerful enough, or this could be just a question of chance. We observed a convergence of results with the epidemiological approach and the experimental approach, which should suggest an absence of indication of reduction of the survival rate related to the use of cell phones, including intensive use among patients with glioma. Thank you. And here we have the 2 publications on neuro-oncology. Thank you. Do we have questions in the audience on this presentation? Are there any questions? Here we do have a question. Here in the 4th row in the auditorium. It seems that I thought I saw on the next to last slide that there was a difference between the control rates and no, there's no significant difference here. This representation does not show the variability, and these curves, in fact, group together on terms of variability. But there's a trend, nonetheless, between the control and the sham. Even if it's not significant, there seems to be a trend. There's a package of shams and exposures, and then the control seems to be behaving differently. Yes, visually, that's true. It looks like there's a trend, but in fact, statistically speaking, this doesn't appear because the variability is not sufficient to be considered significant. It doesn't enable us to confirm a significant effect. We have 15 animals, and in order for this to correspond to your hypothesis, we would have to start with more animals so that we could verify that hypothesis. And in fact, this data is not sufficient to affirm that because the data is not significant enough. Thank you. We're going to take one more question. Hello, my name is Raphael Levitch from the Zone Blanche Association. I have a question for Yves Le Dréan. Can I ask that now? Thank you for having included that question mark, because it brings up the question of what a researcher does when they come up with conclusions that are contrary to what they're expecting. This is something that we saw already this morning. For me, the interpretation of that, the last part of your presentation, in other words, you were expecting an effect, a protective effect, and you got a damaging effect related to oxidation stress. And this morning, if I remember correctly, there was another example. In our jargon, we call that a cocktail effect. And I don't understand why you didn't think of that. In other words, why did you not think, well, the toxic effect of oxidation is stronger when there's a radiation beforehand, so that's something to look into. Well, this cocktail effect is something that we looked at compared to the co-toxicity. And when I looked at the results at the beginning, I did see that cocktail effect. And we redid manipulations by repeating the exposure and the chemical treatment at the same time. And in that case, we did not find that the results were not the same. So it was as if the cocktail was not present when we used both of them at the same time, whereas sequentially there was an effect. In other words, first measuring and then applying the treatment. So it raises questions that I don't understand. And as for your first question, what does a researcher do when the results are different? Research is not religion or politics where we have convictions and we're looking to defend our convictions. In my mind, my way of thinking depends on what I see experimentally. So I have a hypothesis. I try to verify it. If the results are not the same, if they're even contrary, then I change my hypothesis and I try to understand given what I see. That's the very concept of scientific research. We're not trying to prove something. We're trying to observe something that can be explained. I am Dr. Arazi, and I have a question for Mr. Schüz. As I listened to the presentation, 3 questions came up in my mind. The first was that you don't mention among the elements related to glioma changes. In France, we have noted changes. We have specific statistics, those from the French healthcare system, which came out just 2 years ago, which shows that there are 4 times more in all age classes of glioblastoma, and that represents 50,000 people in the past few years. And Santé Publique France, the French public health system, does make a cause and effect link with radio frequency waves. So that's the first comment that I wanted to make, and I think it's important for the WHO. It's important that other public health data be taken into account. Second comment, you present studies here, and in the way that you present, for example, a 1 million study in the UK, you present that as if it were the study, the conclusions were final. But in fact, as we just heard, science is all about taking positions and then adapting those positions. You criticize those studies as regard to your positions. Professor Leonard Tarden, for example, and Professor Levis in the US, the former head of American research on the subject. All of these people are people who could contradict what you've just said, and maybe you should recognize that your positions are not shared with a certain number of other experts in the world. And finally, my final point, when you say there's no subject, there's no perception in the industrial world, I think I want to remind everyone again that IARC gives data on studies without specifying that a large number of the participants do have conflicts of interest. And so civil society and other organizations remind you of your duty to clearly and transparently publish conflicts of interest, and these conflicts of interest are not clearly published.
On something, but let me give it a try. So I think your first question was on the numbers of brain tumor cases that are observed in the population, and I mean this is an observation that at the agency we make for all cancers. I mean, cancers on the rise, and the main reason for all types of cancer increasing is because age is one of the major drivers of cancer. So as you hear from the agency that we predict a doubling in cancer rates over the next 20 years, and brain tumors is no exception to this. I mean, I showed you the incidence rates also in the Nordic countries, which are the true incidence rates on the last slide. And if you transfer this into absolute numbers, then of course there is an increase. This is why we don't use the incidence rates to really confirm or refute any conclusions on the mobile phones. What we used it for was a consistency check to see whether studies that were done on mobile phones and brain tumors are consistent with reality or not. And here we see that many of the case control studies that have previously observed an effect are not compatible with this reality, because we would expect a different shape of the incidence rates. So I think this is probably all I can say to the incidence rates. I think the second question was about the UK million women study. I mean, I think if you read our paper, we have been very transparent in acknowledging limitations the study have, and I've repeated many times, this was not a study specifically for mobile phones and brain tumors. This is why, as IARC, we have been fighting so long for conducting the COSMOS study, because this is really the study which was actually planned already back in 2003 at the research agenda meeting at WHO, and it took a long time to implement this study. That we need this very specific study where we oversample low users of mobile phones, where we oversample heavy users of mobile phones, to have this contrast in the population, and where we make a major effort to get detailed exposure information from questioning the people, but also from getting operator data, the traffic record data of the individuals, which is not easy to get, because most people don't want to share their mobile phone data, because it probably tells more about their behavior than they would like us to know. So you can imagine how difficult it is. So we have been always fighting and doing the COSMOS study. But, you know, in the meantime, we still have to provide the best evidence that we can. And the UK Million Women study was an opportunity. It does not answer all the questions we have about mobile phones and brain tumors, but it answers some, because even if you model different error scenarios for this study, you can come up with conclusions. And I think no one of the authors says this is the conclusive study, because we are still doing the other studies to complement this activity. But it still gives insight in the meantime, where we have an exposure that everyone in the population uses. So we have to use every evidence that we can get hold of. And the UK Million Women study was a good piece of information on this. And I think the third question was about funding again. Yeah, I mean, you can see a lot of the IARC activities are actually sponsored by ANSES. Thank you very much. The glioma study was funded by the German government. The Interphone study was funded by the European Commission, and half of the money came through a firewall to the agency, because at the time that we did Interphone, the European Commission said, you look, why should the taxpayer pay for all the research on whether mobile phones are dangerous? There are companies who make a profit with these devices, so somehow they have to pay too. And then a really expensive mechanism was thought of, that money was given by the manufacturers to a neutral partner, the Union Internationale contre le Cancer, a trustworthy party that would then have the contract with the agency. So I find it a little bit disappointing that all the time we are hearing about this funding, when in reality we even paid money to protect the study from vested interest. And I mean, I'm not kind of clean washing everyone who's ever been working in the mobile phone wage, but I think for the studies that IARC is doing, also because of the responsibility we have to our member states, and being an impartial member of the United Nations, we make an extra effort to protect ourselves from vested interests.
Just to, si je peux complémenter, parce que les noms...
Because you mentioned IARC, I've been director of IARC since 2019, and I've signed all the contracts, and I've written all of the I've read all the fine print, and I can assure you that we do not get any information, any money. We haven't had any since I've been this is not a debate, this is a statement, and I will not give you the floor again, because I read everything that I sign, and since I've been director there has been no industrial money coming in to fund these studies.